So regarding order of operations, to better explain this, we're going to expound it with an example. Here we have an equation that's solely in terms of variables a, b, and c and d, and we are tasked with solving for d. And when an equation says solve for d, it means get d by itself on one side of the equation and everything else on the other side of the equation. So the way that we're going to do that is I have to, when I'm manipulating or moving an equation, I have to constantly think I need to undo things. And it's almost like doing PEMDAS or the parentheses, exponents, multiplication, division, addition, subtraction backwards. So before I can get d by itself, I need to move this minus b squared to the right-hand side of the equation. So I'm going to rearrange the equation down here just so you can see the manipulation that I'm going to do with it. All of that is squared minus b squared equals b squared. And what I do to one side of the equation, it's okay, so long as I do it to the other side as well. It's still an equation. So I have to add b squared to both sides. I'm left with d squared minus b minus ac squared is equal to, I can add like terms to like. So b squared plus b squared becomes 2b squared. And now I have these two equations that have both squares. Now, under other circumstances, when we take the square root of something that has been squared, I need to consider it can be both positive and negative. We're not going to do this for this example, but we will see that in other cases, and I'll explain it when it happens. But again, what I do to one side of the equation, so long as I do it to the other, it's still an equation. So I'm going to square root both sides. And squaring a square, it undoes the square root. So on the left-hand side, I get d squared over b minus ac. And now I don't have to add the parentheses because parentheses were stating that I had two of them, and now I just have one of them. That is equal to, I can simplify this to the square root of 2, and then the b squared square rooted gets to be b. I need to add ac to both sides. Now, root 2b and ac, they are not like terms, so I cannot simplify them together. So I would write it like this, d squared over b as equal to the root of 2b plus ac. And then I still want to get d squared by itself. So b is being divided. I'm undoing division by multiplying it to both sides. Now, because of the addition sign here, this is where the PEMDAS or the order of operations is extremely important. Because of this addition sign here, that means I have to distribute when I multiply b squared, because multiplication is on a higher order of operation than addition. So on the left-hand side, I get d squared. That is equal to, I can just distribute it or I can leave it by itself. I'm going to choose to distribute, and by that I mean I'm going to multiply it into each of the expressions. As you'll see, we get a b squared here. It's root 2b squared plus bac. And then I want d, not d squared, so I can take the square root of both sides. And since there's an addition sign under the square root is kind of like an exponent. I can't simplify that with an addition sign like I could multiplication. So this becomes d is equal to the root. You see we have a double root here with root 2, but that's okay. Root 2b squared plus bac, and that is my answer.